Okay, here we go. Let's take a look at this. So,
There's no way I could have done that.
so if we set this up using long division, which we're gonna make our division bracket. What goes inside? The top. Okay, good. So tell me what I write in there then. Okay, at this time, there were no missing terms, but let's say that there was no x squared. What would I have to do?
Plus 0.
Put a 0x squared in there. Okay, and then the denominator goes, there is an x squared. But if there weren't, I'd have to put a 0, right?
Just 0.
It's, well, 0x squared. So we know that's the x squared column. Yeah. Okay, so the denominator goes outside. Okay, I'd like everybody make sure you're pivoted in your desk facing forward. A simple instruction, but I'd like everybody to do that. Thank you. Oh, there we go. Excellent. Thanks. Okay, attention up here. All right, so what do we do first with long division? We divide. We divide what by what? We want to see how many times what divides into what? X into 2x to the fourth. Good. So the first thing we want to look at is we're going to ask how many times does the leading term outside go into or divide into the leading term inside. And so let's find out. We'll just set up a little quotient and see. So 2x to the fourth divided by x is what? 2, and then x to the fourth divided by x to the 1 is x cubed. Okay, so we get 2x cubed is the first term. Okay, what happens when now what? What do I do in long division? Multiply. So I'm going to multiply the 2x cubed. I'm going to distribute it to both parts of the polynomial out front. I have to multiply by the whole polynomial, which means distribute. So 2x cubed times x is?
2x.
Good. 2x to the fourth. 2x cubed times 2 plus 4x cubed. Now notice I'm lining those up in the appropriate columns, right? So they're like terms line up with like terms. Then what do I do? Subtract. I'm going to subtract the whole thing. So 2x to the fourth minus 2x to the fourth cancels. And it needs to, right? That's the whole process of long division. Each time we get a term up here, we're getting the term so we can cancel one term out of the original polynomial. So we just whittle it down step by step. So this is going to be an x cubed column. 3 minus 4 gives me negative 1. So I get a negative x cubed. And I'll bring down the other terms. And then we just repeat the process, right? So now what do we get? So we get negative x cubed divided by x is what?
X.
Okay, but I got a negative there, right? So I got negative over positive is negative x squared. So that's the next term. What do I do? Multiply. So negative x squared times x is negative x cubed, right? Negative x squared times 2, negative 2x squared, agreed? I'm going to put parentheses around the whole thing because I'm subtracting the whole polynomial. And what do I get? You gotta be very careful. This is the step where people will make mistakes. You gotta be real careful with this. So x cubed, negative x cubed minus negative x cubed, 0. Cancels. Good. Now I'm in the x squared column. What's negative 1 minus negative 2? No. Positive 1, because when I subtract a negative, I'm adding, right? So I get a positive 1 x squared. I'll bring down the other terms, and we'll go again. So x squared divided by x is what? X squared divided by x? X. Good. So we get a plus x. And really, another way of saying that, right? You could also probably just say x times what is x squared? Well, x. Right? That's a little quicker way maybe of doing it. Now we distribute again. So x times x gives me my x squared. X times 2 gives me my 2x. I'm gonna subtract the whole thing. The x squareds cancel. Negative x minus 2x is negative x minus 2x, negative 3x. Then I bring down the 8, okay? And then now this is my last step, isn't it? Right? Now, how do I know? Well, look at the terms up here. I've got an x cubed, an x squared, and an x. And so if this divides in, this would be the constant, and that's the last hurrah, right? I can't go any further than the constant because this is going to end up being the polynomial part of my answer. And the last term in a polynomial is the constant, right? So this, if we can even do this, it's the last step. Well, can we? X times what is negative 3x? Negative 3, right? So I'm going to get a negative 3 there, right? And I'm going to distribute that through. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. And then we're going to subtract the whole thing. And what do I get? Plus 2. Hang on. Sure? Negative 2. Negative 8 minus negative 6 would be negative 8 plus 6, which is negative 2. And that's my remainder, isn't it? And we know that's my remainder because that's a constant, but also because x won't divide into that anymore, right? So we're stuck with that. So what does that remain over then? If we go up and write our answer down, what's our answer going to look like? So I hate to get rid of that stuff. Let's go, I'm just going to do this. So we end up with, this is the polynomial part, right? So there's the polynomial part, right? And now we need the remainder part. Agreed? Okay, what's the remainder part going to be over? X plus 2, because the remainder is what remains over the denominator always, right? So the x plus 2 is in the bottom. If we go back to this other page, what was the remainder? Well, negative 2. Okay, so that's our answer. Okay. This big polynomial divided by x plus 2 gives us that polynomial plus this number plus that fractional remainder, right? Okay. I want to show you something that's a really great shortcut. I can't remember how far we got yesterday, but I don't think we did this with you guys. So what if we wanted to use the same process we did for synthetic substitution, right? We'll review that now. It's a good thing to review anyway. So like, for example, we did that yesterday if we wanted to plug a number into a polynomial to evaluate it. And the answer just came out in the box at the end of the synthetic process, right? Synthetic substitution. Well, let's do that again, only this time it's gonna have a different meaning. So here's our bracket. Remember how we set this up? We get a little bracket where our number goes, and then we leave room for 2 rows, right? Okay, we're gonna put in the coefficients of the numerator in here, right? So those go in row 1. What are those coefficients? 2. Okay, and then underneath the negative 8, we put the box where our answer was, right? And let me just draw some little, so we can see where we're getting these. Here's the 2, there's the 3, there's the negative 1, there's the negative 1, there's the negative 8, right? Okay, now the way we did this with substitution was, whatever number we wanted to plug into the function went out there, but it's a little different with this process we're learning now. This is actually going to be called synthetic division. What we do this time is we're going to take the 0 of the denominator. So the 0 of x plus 2. Well, what is that? If I said x plus 2 equal to 0, what would the solution be? Negative 2. Another way of thinking about that is, what's the number that would make the bottom equal 0? Negative 2, right? That's the number we put in the box. Okay. Now let's go through this process, and I want to see if you can recognize a pattern here. So remember how this process worked, right? in order to start the ball rolling with synthetic substitution, or in this case, synthetic division, it's the same thing. We have to get a number to appear below the bar. So we're going to take the first number to start things off and just drop it straight down. Now, what's the rule? Whenever a number appears below the bar, what do we always do? Multiply. Good. So 2 times negative 2 is negative 4. And then whatever that product is, that's going to go in the second row of the next column over. So we're going to push it up diagonally. Right? 2 times negative 2 is negative 4. What do we do? Not subtract. We add. And that's, I'm glad that brought up, because that got brought up. Synthetic is the opposite of regular division, right? When we're doing synthetic, we add. With long division, we always subtract, but synthetic is going to be the opposite of that. We're always adding. So 3 and negative 4 is, okay, a number appeared. What do I do? Multiply. Negative 1 times negative 2 is 2.
I have a question. Can you, you know how we're just dividing? Can you do this to not do all that dividing?
In some cases, you can, yeah. That's why I want to show you this. This is much, much easier. So negative 1 times negative 2 is 2, right? I add. 2 and negative 1 is 1. 1 times negative 2, negative 2. I add. What's negative 1 plus negative 2? Negative 3. Negative 2 times negative 3 is 6. And if I add those up, I get negative 2. Now you tell me, do you see a way that this stuff right here represents our answer up here? Do you see a way?
You just put the x's back in and then it's.
How about that? Those are the coefficients, aren't they?
So can we do that? So we don't
Yes,
do
you
all
can.
that?
Now, here's the deal.
The dividing.
Of course, the question is, which one's obviously much, much easier?
This one.
This one. Okay, synthetic division is a great shortcut, but here's the limitation. It only works if you're dividing by linear factors. So what I mean by linear is, let's remind ourselves, that means that whatever the polynomial on the bottom is, the biggest power of x is x to the 1. So unfortunately, the one that we did yesterday, where we had a quadratic in the bottom, you got to do long division for that, which is unfortunate, because that's a long process, right? I will make you, just so you know, on the homework that you've already started, I think I didn't give you very many problems. I think I only gave you 3 long division problems, and 2 of them are a little bit easier, right? So you got one that's kind of like the one we did yesterday, and 2 that should work out a little bit easier. I gave you 3 synthetic division problems, which should take you a grand total of about 5 minutes. And I gave you 3 synthetic substitution problems, which will probably take you about 3.5 minutes, I guess, if you really crank through them. Once you get the process down. But you see what's going on here, and there's one more thing I want to reinforce with this. When you get this answer, so whatever's in the box is the remainder, right? So how do we interpret this when we do synthetic division? So we know that this is the part that's going to end up being plus the remainder. What does the remainder go over, of course? Look at the original problem. X plus 2, good. Right, that's the denominator. And so then this is going to give us, the remainder box is telling us we're going to end up with a negative 2 divided by x plus 2. Okay, what do these other ones tell us? Well, these are the coefficients, but it almost helps to work backwards. Because if you start from this end and you have lots of coefficients, it's kind of hard to tell, well, what power does that go with, right? But I know what power that goes with. The first number there, and it might be a 0. If it's a 0, we just wouldn't write anything. But what does that go with? The constant, x to the 0, right? So that's going to be the constant, that's going to be the coefficient of x to what power? The x to the 1. So there's the constant, there's the coefficient of x, that's the coefficient of x squared, coefficient of x cubed. If I kept going, that would be x to the 4th, x to the 5th, if there were more numbers, right? So it's much easier to start on the right. So we're going to get, we know that's going to be constant x, x squared, x cubed. So this is just going to be 2x cubed minus 1x squared plus 1x minus 3. How about that? Okay, way easier, right? Okay, go.